Hello guys, so in the last video we have seen the dot product and the cross product a little bit. Today we will go more about cross product, but before going, just a recap that the dot product is called a scalar product as the result is a scalar quantity. So basically if you have something like this, 2i 3j and one another vector is 2i dot 2i minus j cap, so in that case the I component will be multiplied with I, and 3 that means j component will be multiplied with j component, and we will get a value only. And as an example you can say w equal to, that is work equal to f dot s, that is force into displacement into cos theta. So this is called a scalar product because our final result is a scalar quantity having no direction. But in the cross in the cross product we have seen that a cross b will be ab sin theta and n cap. And the last video I was telling you that that this n cap will be perpendicular to the plane in which a and b vectors are. So if say I have a vectors and I have b vector, and if I want to do a cross b, so I have to move my hand from a to b, that means my right hand, and my thumb will direct the direction of my final vector. So you can see one more thing, that if we do b cross a, in that case my thumb will direct down, that means I'm using right hand rule here, so you have to do right hand rule here. So when you are using your right hand rule, so your thumb will direct down if you go b cross a, so that means that one should be down one, right? That will not be the up one. So that means one thing is basically clear, that my a cross b, the direction of a cross b is opposite to the direction of b cross a. That you have to be very much clear, that a cross b and b cross a is not the same thing. Moving to multiplication, like in dot product we have seen how to multiply two vectors if they are given in component form, that is this one. But in this case cross product, what we are going to do, before going into that, I have to see that, like we know that I dot I equal to 1, right? But in this case let's see how I cross I is equal to 0. Like I cross I will be then the value of I, the value of another I, then sine theta. Now the same vector, the same unit vector, that is I, is making an angle 0 with itself. So sine 0 is, and obviously there will be some direction in cap, but sine 0 is basically 0. So basically the whole term is 0 in that case. But let's say we have I cross j. So in that case you can see that if we do this I cross j, one more thing, basically going into this thing, you can see that whenever two vectors are there, one more automatically direction like n cap is coming, that is not in that plane. So cross product cannot be in two dimension, okay? Like it has to inculcate the three dimension also, because a b can be in one plane, that is in two dimensional, but the result of cross product is always in the perpendicular one to the plane. So ultimately you cannot tell that the cross product is basically confined into two dimension. So automatically your k cap, that means the z direction, is coming here, right? So if I don't write also any z component here, that is k cap, but still a cross b will involve one direction along z, that is the k cap. So I j k, they all are necessary in case of cross product. So you can see that if we do this, I vector value, j vector value, sine, the angle between I and j is 90 degree, and then we have n cap. Now this n cap, instead of writing n cap, I will write here k cap, because if you draw here, that is my I, j, so I am coming from I to j. Okay, now one thing will happen. See, basically I, j, k we write like this, right? That means my k is horrible, so I will write again. Okay, so that means if I go from I to j, my thumb will direct downward, that is your minus k, right? So this one will be the minus and a k cap. So the result will be minus k cap. So it will be minus k cap. So I cross j is your minus k cap. But if we try your j cross I, you can see now if I go from let me just move. So if I go from j to I, that is I'm moving like my right hand in towards I, so my thumb will indicate k, so that will come k cap. So in case of like your this what you say cross product, one thing is clear, that the like terms vanishes and the unlike terms become the perpendicular direction. Like it's basic. Now the sense matters, like I cross j is your minus k cap, because the direction of my thumb while going from I to j is showing downward, and my j cross I is k cap. So basically these things are important. Okay, so basically I think we should not use any like trick, but we should draw and see, because that will be much more easier. Now coming to this one, how to like do this, like if you have in component form I cap plus 2 j cap plus 3 k cap, and another vector is given I cap minus 2 j cap minus k cap. Now you can see that these vectors are different, but how to do a cross b? Now so for doing a cross b, something you have to learn, that is called the matrix and determinant. Now you have to find out the determinant. Now what is determinant? Just I am giving a little bit about it, okay, but not the full. Once you learn that, we can again do this stuff. So you first have to write all the components, like all the direction, that is I, j and k in the upper hand, like at the top corner, that is the first row. Now in the second row, what you have to do, you have to write the components value of the first vector, that is with I cap there is 1, with j cap there is 2, with k cap there is 3, and then the last column, row, you have to write the components of b vector, that is your I, that is 1, minus 2, that is for j, and minus 1, that is for k. And then you have to find out the values like this. First you have to take your I value, and you have to consider these terms. So I into, so multiplication will be like this minus this, that means 2 into minus 1, so 2 into minus 1, I'm just showing 1 and the rest one I will just do it, okay. So 2 into minus 1 minus 2 into 3, so it has to go like this, okay. So the first one is done. The next one, what we will do, now we will remove this one because my I component one is done, and then again I will do J, and this time I will consider this and this. Okay, so how to do this? Let's see. So what I will do, I will write minus now this time. So first one I have to give plus, the second one I have to give minus, okay, in my mind, and then the next one again plus. So minus J now in bracket. So with 1 I have to multiply minus 1, so 1 into minus 1, then minus again. Now 1 and 3, so 1 into 3. Okay, my place is not fitting here, so whatever. Again, so my minus, that is J, is done. And at last I have to do this for K. So for K, this I have to consider. Okay, so for K, this I have to consider. So I into, you just look once very carefully towards my this calculation. 1 into minus 2. Okay, then minus your 1 into 2. So I'm not writing because not place is there, so I'm writing 2, the result only. So whatever you will get, that will be obviously a vector quantity because you have I, you have J cap, and you have K cap, and these inside are the values, right? So basically what I am doing here is called finding the determinant, but you will learn this in your math. Once you learn it, you just come back and see this procedure again because you will be needing it. So this is the way of finding cross product for two vectors which are given in component form. Now the next thing, you have seen this, I am doing from like this. When you have this kind of like arrangement and you have to find the value, determinant value of this thing, what you have to do, you have to multiply this, then you have to subtract the multiplication between, like, product of this. That means AD minus CB. This is the procedure. Okay, now in case of 3, like 3 cross 3, that means you have total 9 components. You have to do like this. You have to take the first component, then you have to consider this much as your like determinant, and again you have to consider the second component, and then you have to do again the first and this as your components, and at last you have to consider the K cap. When I am considering K, I have to do this much. That means when I am considering K, my whole this part I am neglecting. When I am considering J, the whole this part I am neglecting, and when I am considering I, the whole this part I am neglecting. So I am doing only this much. Okay, so this is basically a little bit it will take time for you to grasp because it is very new to you and you don't know this thing correctly. But in physics we need those things of math so that we can go further with the numericals. Okay, now something why I'm showing you this thing, because like if you are given with component for the dot product, you can do easily, but if you are given with this component for component form, the cross product is little bit tricky. Okay, now something is there which is called vector triple product, and that is basically very interesting thing. That is like this, that is a mixture of your dot product and your cross product. So see, this thing is basically your just a minute, this is basically your triple product. Something happened, triple product. My stylus is not working today. Okay, now what is the use of this thing? Okay, the use of this thing is your finding the volume, to find the volume. Like let's say you have something like this. Wait, let me draw a nice okay, let's say you have a cuboid like this. Now the area, already we have seen that whenever we are having some kind of area like this, I should not write it like this. Okay, fine, let me draw it. Let's say I have a area like, I have to find some area like this. So we know that area is a vector quantity, and the direction of the area, so let's say this is my vector A, that is my side A actually basically, and this is my side B, that is a vector also B. So the direction of the area will be perpendicular. Why? Because the area in vector formulation, we write the area as A cross B. Now you know that A cross B definitely will not only have a value but also will have a direction, and the direction will be my n cap. So the direction of any area or any surface will be upside, that is perpendicular to the plane of that surface. Okay, in a similar way, so this is very important. Okay, you must remember this key area, the direction of any surface or the direction of area is always perpendicular to the plane of that surface. In the same manner, if you have three sides like this, if you have, say, this is B, this is your C, and this is your A. So in that case, you know that B cross C is upward, and with A, see, ultimately what you are doing, this will result a vector, and that vector is getting dot product with A vector. So ultimately my result will be a scalar quantity, right? And I know that my volume is a scalar quantity. So to write the volume of any cuboid, we use this triple product, okay, to like express the volume of any cuboid. Or this situation may comes in your further study, and we will see there this kind of term is coming. So these two more things are important also. Now so basically with this we will end our vector analysis, the like basic ideas about vectors, and then we will go further one into our projectile motion, like for which we were reading these vectors. Okay, so projectile motion is what? Projectile motion is nothing but destroying with missile or something like that, destroying your enemy with a missile or something. So if you launch anything, so you can easily imagine that it will go like this and it will drop somewhere. So we will basically analyze how it is happening. Okay, so in the next class from onwards we will be studying about projectile motion, and there are a numerous number of numericals we have to solve. Now today I will go a little bit about this. So see, basically projectile motion occurs in two dimensions, so that's why it is called the motion in a plane. This chapter, one direction is your x-axis, and another one is your z-axis. So this is z-axis. But instead of writing z, you will see that in your book generally it will be given as y-axis. So that is the height one, that is vertical, and your horizontal, that is the x one. Now basically if we do this whole thing considering only one vector, that is my velocity, total velocity, then there will be so much problems for us to like calculate all the things. So what we do basically, we basically generalize, not all generalize, we just split the components of this resultant v vector, velocity vector. So what we do basically, we take the portion of this v vector with what we are launching the missile, okay, along horizontal and along vertical. That means how much of this velocity vector is working along horizontal axis, and how much of this velocity vector is working along vertical axis. That means how much is responsible to pull the missile vertically, and how much is responsible to pull the missile horizontally. That means from this place to this place. Okay, so we know that if we take theta to be the launch angle, then if v is the velocity, so this component, that is the vx component, will become v cos theta, right? And this is I'm talking about only the value only, okay, only the value. And my this component, that is y component, will become vy equal to v sin theta, and this we have already talked. So v sin theta. Now we will basically have one dimensional motions, like two one dimensional motions to deal with. So if we do the whole thing with only v, that is the resultant velocity, then we have to do it like very we have to we have to face many hurdles in this way. But if we split these two terms in terms of vx and vy, so we have two like one dimensional motions. One is the motion that is occurring just for the horizontal displacement, and another one is the motion which is occurring just for the vertical displacement. So in the next class we will be talking about this very analytically, how this is happening. We will also see some of the simulations, and then we will solve some numericals also. For today, this much is the class. So again I'm telling a little bit that area is a cross product of two side vectors, and the direction is always perpendicular to the plane of the area or the surface. The vector triple product is a mixture of cross and dot product, and it represents the volume of any cuboid or something like that, and it is a scalar quantity. We also learned that the cross product basically a little bit tricky to do it. The cross product is having a direction n cap, basically, which is nothing but like area almost, that is always perpendicular to the plane in which a and v vectors are there. if you have two vectors like in components form that like this, so we have also seen that finding the cross product between them is a little bit of tricky, and we have to take help of determinant, and we will learn this. Fine. So this much is today for today, and in our next class there will be an online class, I think, or I will first explain this in the video and then we will talk about it. So bye bye for today, and in the next class I'll meet you soon.